So the lesson will be about the exponentials and logarithms, and I'm Kate. Hi guys.
Hi, Kate.
So solving exponential logarithms. So in order to solve an exponential equation, you need to take the log of both sides and then solve for the variable. So problem number 1. Here are like a few tips in order to solve this problem easier. So first, looking for the smallest variable on both sides have in common. That's what you should do. So here we can see that we have 4, which it can be equal to 2 to the second power. And then we have second tip, which is am equals an, and then we can eliminate the bases and we will be left only with m equals n. So that will be easier in order to solve our problem. So let's start with this one. Yes?
I'm sorry, is that like the log, or is that just a number that you can factor out both?
A is the log, and then mn will be the number which we will be left with.
Okay.
And I'll explain it more when we'll have the problem.
Gotcha.
So our problem is 4 to the x power equals to 2. And in order to make the same basis, we have to, as I already said, 4 we make it 2 to the second power times x equals to 2 to the first power. So now we see that we have the same basis, right? So a and a is the same basis right here. See them? And now we have to just bring 2x and 1 down. First of all, we have to multiply 2 and x. And so we see now for sure that they're almost the same. And then we bring them down. And we just left with 2x equals 1. And now just simple math. 1 divided by 2. So the answer is 1/2. Let's look at a little more complicated problem, which is e to the 4x minus 1 and equals to e to the second power times x. So we need to multiply 2 times x, because that's the first problem in order to have the same basis. So we multiply them, and that's what we get. And now we have a common base, as we can see, and on both sides, so we can just simplify. So we go down, we drop those 2 down, we get 4x minus 1 equals 2x. Simple math. 4x minus 2x equals 1. We just bring 2x to this side, 1 to this side. And then we're left with 2x equals 1. And again, the answer is 1/2. Any questions so far? Nope? Great. Let's go to the next problem. This is again a small tip to do this. And this is the formula. So when we have this kind of setup, an exponent can come in front of the natural log. So n as an exponent can come in front right here as a coefficient. So in order to solve this problem, we can see that we cannot just have the same base because 7 does not simplify to 3 and vice versa. So 3 to the x equals 7. So the bases are different. So we use the logarithmic rule, which is right here. So we'll write natural log of 3 to the x power equals natural log of 7. And we bring the exponent in front, which is x, right here, as you can see on the next step. So we have x times natural log of 3 equals to natural log of 7. So now we'll have to divide both sides by natural log of 3, which is shown right here. So we'll have x times natural log of 3 divided by natural log of 3. So we can have equal to natural log of 7 divided by natural log of 3. And as we divided it, we'll get natural log of 7 divided by natural log of 3. And now this process our calculator can do, because it's the simplest way. And you just plug this into your calculator, and the answer which you will get is 1.77. Now, change your base formula. Yes? Sorry. Previous question?
It's going to be a stupid question, but can you cancel out the natural logs?
No.
Okay.
No, you don't cancel them out, because in order to solve this problem, you have to plug the natural logs in.
Okay.
You know, like you cannot just have the same base. You have to use the logs.
Okay.
So like solving the ln7 would come before dividing it. If I plugged in ln7 into my all the way at the bottom right before the answer, if I plug that into my calculator and I got a number, and then I would have to plug in ln3 and get a number, and then I divided that, that's would be 1.77.
Yeah, exactly.
Okay.
Exactly. So it's easier if you do like step by step than plugging it all in, so you avoid the mistakes on the calculator. You know. So when you plug this in, divide by ln of 3, and you'll get 1.77. Good. Anyone have other questions? Great. Let's move on. Now, change of base formula, which will make your life much more easier. So each exponential equation can be solved by writing a log equation and then using a change of base formula. So change of base formula, let a, b, and x be positive real numbers such that a cannot equal 1 and b cannot equal 1 either. So then log base a of x can be converted to a different base using any of the following formulas, which are right here. Base b, which is any base log, and the formula will look like this. Then we have base 10, which is a common log, and this is the formula. And log e, which is a natural log, and this is how the formula will look like. So all of those can be plugged into your calculator because they're set up there already. Any questions? Move on to a problem. So problem number 1, 3 to the x power equals 7. So in order to solve this, we need to put log base 3 to both sides, so we can cancel this out. Okay, so we have log base 3 of 3 to the x power equals log base 3 of 7. Now, we cancel log base 3 and 3, they cancel out, so we will be just left with x. So we have x equals log 7 over log 3. So, what we did here, we used change of base formula. When we're using change of base formula, 7 will come on the top and 3 will come on the bottom. Those are the formulas which you saw on the previous slide, and they're explaining exactly how to do that. So this is already using a change of base formula. So now we just plug this into our calculator, log base 10 of 7 divided by log base 10 of 3. And we get the answer, which is 1.77. Any questions? So, if you notice, the two last problems were the same. So we could use logarithmic rule, like we did here for one of the problems, and change of base formula for the other one. So you can use both ways. It doesn't matter which one is easier for you. That's the one you can use. See? Yes.
I'm sorry. For that last one, is it just log of 10 or is it the log of 3 still?
So when log in base is not written, that says that it's 10. Log base 10.
Okay.
Every single time it's not written, it is because the calculator it's already set in there. So that means that log base 10 of 7, log base 10 of 3.
Okay, gotcha.
And if it's written, then it's in any other log. So any other log which we don't have in our calculator, okay? So it will be written. If it's not, then it's 10.
Gotcha.
Make sense? Okay. Let's move on. So let's do more problems on change of base formula. So 5 to the x power equals 476. So anybody who wants to try this knows what the next step will be? Yes?
You put the log of 5, I'm assuming.
Great. To both sides, right?
Yeah.
Yeah. So we put log base 5 of 5 to the x power equals log base 5 of 476 to both sides. Great tip. Now, we use change of base formula, right? Yes. So we cancel out log base 5 of 5. They cancel out. And we're left with log base 10 of 476 divided by log base 10 of 5. We use change of base formula. Makes sense to everybody?
Yes.
What do we do next?
Plug in the calculator.
Great, guys. And the answer will be 3.83. A little more complicated problem, not that much, but I think we can handle it. So, what do you think we should do? What our first step will be?
Divide
Divide
4.
by 4.
Great. So we divide both sides by 4, as it's shown right here. We divide this, and then we will be left with 3 to the x power equals 246.
Then we do log of 3, or x
Yeah, log of 3 for both sides.
Yeah,
Good job, guys.
And
Yes.
then it cancels out, we get x equals log of 246 over log of 3.
Log 3. Yes. And what the base is here?
10.
10.
Job, guys. And we'll plug this into our calculator, and the answer will be 5.01. Job, guys. We got this. And now a bit harder word problem. Let's go. You'll see one of those in your exam. So, that was the problem state. Suppose that the factory is producing 10,000 units and they can produce up to 15,000 units. Their production rate is growing at a rate of 3% annually. That will be the time when they will reach their production capacity. So, a quick tip, using compound interest formula, we'll get to the time and the factory reach their production capacity. I'll show you the formula on the next slide. So the first step which we will do, we'll have to find every year which the production will be at more than the previous year. So we'll get 100% plus 3, which is 103%, and that is every year the production is 103% of what it was the previous year. And that's what we need for the formula. So the common mistake which people would do, they would plug into the formula 103. But that's wrong. We have to change 103% to 1.03, which is now we can do the formula. Let's see the setup of the formula. So, as we would do the formula, it will be 10,000 times 1.03, not 103%, to the t power equals 15,000. So, now we'll have to divide both sides by 10,000. And we will get 1.03 to the t power equals 1.5. Now, what will we do?
The log of 1.03 to both sides.
Yes, exactly. So that's what we do. Now it's just the math which I showed you before about using the logs and bases. So those two will cancel out. We'll be just left with the change of base formula, which will be t equals to log base 10 to the 1.05 divided by log base 10 of 1.03. And we plug this into our calculator and we'll get 13.72 years. So now we can see that how a real life example can be done with change of base formula. This is used in the factory will reach their final production capacity in 13.72 years. They have time, so yeah. Any questions? Yes.
What theme was your presentation? I really liked it.
Actually, it wasn't a theme. It was all black, but then I added up color.
That is really cool. Props to you.
Thank you. Yes.
Have you ever thought about being a teacher?
No. I knew I would never want to be a
You did
teacher.
good. No, you did good.
Really?
Yeah, you're really
I thought I
good.
could never explain.
No, you did really good.
No, you got it.
Thank you.